Hi, and welcome to Lambda U. My name is Jessica, and I'm a Solutions and Support Scientist for LICOR. In the previous courses of this learning path, we discussed all the steps that you take to prepare your NIR Western blot. In this course, we will discuss the best practices for obtaining an image of your Western blot, stripping your membrane, and reprobing it to detect new targets. As a postdoc, I imaged my blots using chemi detection on film. I never considered switching to fluorescent detection because I liked film. Film was easy to use. I was able to see my target protein as long as I exposed the film long enough. So I really understand scientists' reluctance to switch from a protocol that they know is working to a new technology such as NIR. This unfamiliar technique could make people a little hesitant. However, as we've discussed in previous lessons, with the appropriate optimization, NIR can be as sensitive as chemi. Also, the NIR signal is more stable than chemi, which will lead to more consistent and accurate data. Optimizing your Western blot protocol will require time and effort, so you really want to make sure that you follow the best practices when acquiring your image. As Andy has previously discussed, there are many aspects of the imager that can impact the quality of your image. In addition to the imager, there are also other considerations to keep in mind when you're ready to acquire your image. When you're imaging your near-IR blot, you can image it either completely wet, which means that it's covered in buffer, or completely dry. If you're imaging your membrane wet, make sure that it's completely wet. If you're using a laser point scanner, you can place the membrane in the imaging glass and then pour a puddle of buffer on top of it. Using the roller, roll out all of the bubbles, as these would appear as artifacts in your image. Make sure that your membrane is evenly and completely covered with buffer. If you're using a camera-based system, add a bit of buffer on top of the membrane, but not so much that it can lead to a significant light diffraction, and remove any air bubbles prior to acquiring your image. Now, I know it may sound a bit weird at first, but you can completely dry your membrane and then image it. If you're going to image your membrane dry, first rinse the membrane with distilled water to remove any residual salt, and then place the membrane in between two pieces of filter paper. Make sure you cover the blot loosely with either foil or an upturned opaque incubation box as it dries. This way, we can protect the fluorophores and prevent them from photobleaching. When you're ready to image, if you're using a scanning-based imager, place a silicone pad or piece of glass on top of the dried blot to keep it flat against the imaging surface. Then you can acquire the image of your membrane. If you're using a camera-based system, you can simply place it in the imaging area and acquire your image. To determine whether you should image your blot wet or dry, first acquire an image while it's wet. Then wash the membrane with distilled water and place it between two pieces of filter paper at room temperature for it to dry. It's important to wait for the membrane to be fully dry before proceeding. If you image a damp membrane, not only will you lose the benefits of drying your membrane, but you may also run into the issue of uneven light diffraction. When the membrane is fully dried, acquire another image. You'll then compare the band intensities and background levels across the two blots. Typically, the target band on the dry membrane will have a stronger signal than the target band on your wet membrane, but you'll still need to test this out for yourself. Once you've determined if you'd like to image your membranes wet or dry, you want to make sure that you image your membrane the same way every time in order to get the most consistent results. In the next lesson, we will discuss how you will determine if your band signal is considered significant by calculating your signal to noise ratio.